Other words that they sometimes will use for domain and range when you are taking a look at that. The domain also could be our x values. So when you think of the domain actually could be, if we are looking at this, our x values. Anytime we're looking at the domain, those are really our x values when we just did our x, y tables. And this is our range, it's going to be our y values. Okay? So as you looked at those two videos, as you're thinking about that. So that next part down asks you to identify this function. So if you are taking a look at this one, and you are asked to identify your function, okay? So if you are looking at this one, and it says, if you chose B3, what will you get? So B3 is going to be the Wizard of Oz, right? That's a DVD. So it's like if you go to Redbox, right? You punch in, you say, I want this movie, that's what comes out, right? Will you always get the same thing every time you choose B3? Yes. Unless it's sold out, yes. So will we get the same thing? Yes. Okay. Always getting the same. Does this machine behave as a function? Each time you put that input, do you know what you're getting? Yes. Yes. So this would definitely be a function. Each input has an output. And here's the key thing as we go through this unit. You will always be asked, why? What's your reason? Explain, explain. Key thing. Each input has one output. Easiest answer to put down throughout this unit. So it says, let's make a list of the domain. The domain is all our input. So you could start with A1, A2, A3, right? Then B1, B2, B3. Then C1, C2, C3. Do we have any other options than that for this machine? No. These are our only options on this machine if we are taking a look at it. So then it says, well, what's the range? The range are the outcomes. So one of the first movies you could list at A1, Emma, would be what?
What?
A1.
What?
What would your output be if you typed in A1? What movie would you get?
Gone with the Breeze.
Yes, so we're going to list that. If I put in A2, Grace, we would have
The Godmother.
The Godmother. If I put in 3, I would have Star Ballads, those Star Wars, right? I wouldn't have Wizard of Oz, I'd have Wizard of Oz, and I'd keep listing these, right? So the domain, anytime, or the range of our function, the domain is all of these movies, right? Finding Nemo, Raiders of the Lost Ark, not Lost Ark, right? So all of those different movies, okay? So the domain is what you put in. The range is the output, okay? So I'll give you a minute. Some of you are still copying here. So it says now we're looking at this and we have a steering wheel, right? And the input is you're going to turn, if you keep it going straight, right, you're going to go forward straight ahead. But if you turn it to the left or to the right, what would our output be? Our output would be that you're going to turn right or left, right? If you turn it just a little bit, you'll kind of just turn, your car will go this way, right? You turn it to the left just a little bit. I want you to take a look at the domain. That says, instead of just turning it, it says all possible angles. Meaning, if you turn the wheel 180 degrees, right? If you're going north and you turn it 180s, you're going to go all the way around and you're going to be heading south, right? If you turn it 90 degrees, that means if you turn it 90 to the right, that means you're going to take a right turn. It's going to be a 90-degree angle. But the domain is all possible angles. So you could go anywhere from 0 to 360, right? Or 180, depending if you think about it. What is our range? The range will be all possible angles that the car could turn. So you'll notice that your range and your output are kind of the same. It's the turns, but this is all possible ones, right? You ready, Connor? When you think of that next one down for inputs on a piano key, you're pressing the keys. What's the output if you hit a piano key?
Sound.
You get sound, right? And that's exactly what happens. The sound corresponds to the C. If you hit middle C, you should get that. If you hit a D, if you hit an F flat or an F sharp, if you look at those, okay? The domain, what is our domain going to be? It's all the keys on the piano, right? Could be a combination, like you hit 3 or 4 keys together and it makes a sound, right? But it's all those keys on your piano. what is our range going to be? It's going to be all of the sounds produced by the keys, okay? So that's all of our sounds that are produced by those keys. I have a pencil back there if you need something to write. You push 1, you get apple juice. 2, you get orange. 3, you get fruit punch. 4, you get water. Does it behave like a function? Each input has 1 output. Yes, it's a function. Each input has exactly 1 output. Next, you go into a restaurant and you put quarters into a pull lever. You get anywhere from 0 to 10, it says. Quarters will come out for winnings. Sometimes you win many quarters. Sometimes you win 1 quarter will come out. Sometimes you'll get nothing. Does this behave as a function? Definitely not, right? No. Every time you put in a quarter, you do not know the output, right? It's kind of an unknown. So unless you know each time, can you sit up a little straighter? Can you sit up, please? Okay, good, because we're on that next part down that you've missed, okay? So if we continue in number 3, it says you have a soda machine, you push 1 for Coke, 2 you get a Coke, 3 you get a Diet Coke, 4 you get a Sprite. Does it behave as a function for each input? Yes. And here's the key thing with this one. Each input does give us an output, and it does not matter that the 2 inputs, 1 and 2, both give us the same output. It just means that if you put in a 1, you have to always get a Coke. You do not want to hit a 1, and sometimes, if you've gone to a pop machine and you think, oh, I'm really wanting a Coke or a Diet Coke, and an orange pop comes out, right? You would not want that. That would not be a function, right? You want to always assume that when it says that Coke button for number 1, that you're getting a Coke and not something else, or a Diet Coke or a Sprite, okay? So make sure you put that last part down also. Yes?
Would it be a function if you buy it and you always get something, but it's random?
The randomness part of it will make it not a function. Because, you want to know that you get the same thing every time. Okay? Good question. All right, so that next part in your notes. I'm going to be up here. This is kind of a little more what your homework is going to look like. You're going to be given some tables. And I want you to look at this because it looks a lot like our tables that we just finished in Unit E. So this is our X and this is our Y. Input and our output. So does this represent a function? Does each input give us an output? Yes. And it says, well, what's the rule? So what I want you to think about for the rule, what happens for each input? When I put in 1, when I put in 2, 3, 4, what happens? It does go up by 2, but we are also taking the number and we're multiplying it by 2. So I want you to put down these 2 things. Output equals our input times 2. So Y equals 2X. So what you're going to be asked in your homework is to write an equation in slope-intercept form. Write this down, Charlie. Okay? If you think about this, what is our y-intercept? Plus 0? 0, 0, right? That's our y-intercept. And if we think about the slope, remember what we just did in our last unit, this was our m, our slope. How did we compute that? We said it is always the change in y over our change in x. How is the y changed? From 2 to 4, 4 to 6, it is always 2. How did it change on this side? 1 to 2 by 1. That's how we get a slope of 2. Okay? So you're going to still be using that slope and y-intercept as we're in this unit. Okay? So it says write a rule for the function below. Put your answer in slope-intercept form. That means all of your answers, please make sure you have y equals. M is going to be our number. You're going to have an x. Plus, you're going to have a number for the b. Okay, so keep it in mind from our last unit, slope-intercept form. So first, you're always looking at your input to get your output. So I might write it out this word first in words. Output is equal to what to our input? What happened each time? From 5 to get 9, 9 to get 13, 14 to get 18. We added what? So we're going to put our input plus 4. And if you think of the input as x and the output of y, we are going to have y equals x plus 4. if you're not sure that you did it right, how can you check your slope? Slope, remember, is the change in y over our change in x. If I go from 13 to 18, how much did it change? 13 to get to 18, I add 5. How much do I add to get from 9 to 14? I add 5. 5 over 5 is 1. Didn't we have 1 for a slope in front here? Mm-hmm. Let's take a look at this one. If we're going to think of our output and input, but let's go y and x. What happens to the x to get y? What are we doing each time? Take a look at that. Anyone see a pattern? Raise your hand. 22 to 8, 35 to 21, 45 to 30, 48 to 34. Okay? Anyone see something? I'm doing 55 to get 41, and then do the same thing. See it, Peyton? Subtract 14. So we think we're taking our input, 22, input, right? This is our input, and we are subtracting 14. Does it work for every situation that's up here? Yes. How can we check it? Well, you might want to check your slope, change in y over change in x, right? If we are looking at our change in y, it doesn't matter which one we pick. I might pick this one from 21 to 31. The change is 10, right? What's the change over here? 35 to 45. 10. This is equal to 1, right? Isn't this our slope of 1? Mm-hmm. And if because these are weird numbers, but if I went back and found the 0, I should find it 0, negative 14. Okay? Please try these next two on your own right now. This one is really nice. I give you what's our special one here, but try that first one first. So I agree. 7 times 6 is 42. 11 times 1 gives us 66. 6. 2 times to get 12. So think of this as our x, right? And this is our y. I need to write an equation in slope-intercept form. Y equals, and we're going to put 6x. And if you want to put the times button for a times, put a dot in there, or I would be happy at this point if you're just writing 6x, because you know that means 6 times it. So if we check, x is 3, take it times 6, I get 18. X is 6, take it times 36, I get 6 times 6 gives me 36. This one, what's so special about this one? Why do I love this one that they gave it to us? Called our what, Kira? What's that one? We have 0 for x and it gives us the y. The last unit, y-intercept. This is my y-intercept. So when you're asked to write this equation, right, in slope-intercept form, we've just found this number, right? That is our negative. If you ever have a table with 0, that is our minus 18. So now we need to take a look at our slope. Nikita, what could I be doing to find my slope? So change in y, please write this. Some of you are writing with your pencil at all. Change in y over change in x. How did it change? We added 5. So 13 plus 5 gives us negative 8, right? Negative 8 plus 5 gives us negative 3. So we're adding 5 and dividing Jerica by 1. So if I'm going to write my equation, Zach, my equation should be y equals x. How many x? What did I get for m? So I'm going to have y equals, let's see what we got for our slope here.
Negative 5.
Not negative. We're adding 5, so 5x, and then the minus 18. Could I have plus a negative 18? That's the same as minus 18. So I would take either one of these two answers as you are looking. Okay? Yep, sign off. I'm going to get you your workbook in just a minute. This is not due till Wednesday, right? So when you're doing this, the reason I'm showing you this is that today in class, I want you to know that you want to finish that 13 and 14. If you were gone on Friday, I have the notes for what's on the test. Okay, we're going to look at that in just a minute. I have that video where I was explaining it. I have 3 Quizlets that you could practice if you need more practice with slope and y-intercept and vocabulary. And then these are kind of like some different activities or games if you are done. You do not want to do that if you are not done. So today in class, what we are going to take a look at